right. So your math book is open to page 239. I need everybody sitting up tall. All right, we're going to get to the math book in just a second, but I want us to review a couple of important concepts. All right. So we are working with fractions. Tell me what a fraction is. Charlie? A part of a whole. A fraction is a part of a whole. All right? A fraction has two parts. You're not writing anything down yet. We are just reviewing. So a fraction is a part of a whole. A fraction has two parts. What are they?
The numerator and the denominator.
The numerator and the denominator. Which one is the top number? The numerator. Which one is the bottom number? The denominator. What does the denominator tell me?
How many parts the whole is divided into?
How many parts the whole is divided into, and the numerator tells me how many parts are shaded or how many parts I have. Right? So the denominator tells me how many parts the whole is divided into, and the numerator tells me how many parts I have. Now, what did we learn about denominators? The bigger they get, the smaller the pieces. The bigger the denominator, the smaller the pieces. Why? Why is that true? Elena, why is that true? All right, so according to what you just told me, this is smaller than this. Is that true? Is 1/16 smaller than 1/8? What did you just tell me? The bigger the denominator, the smaller the piece. Why don't you put your arms through your, there you go. Okay, so the bigger the denominator, the smaller the piece. Say that with me. The bigger the denominator, the smaller the piece. So I want you to explain to me why. Why is, so these are 2 unit fractions. I have 1/8 and 1/16. So according to what you just told me, 1/16 is a smaller piece than 1/8. Why?
Because it has a bigger number.
Okay? All right, that is the rule. Now I want you to explain to me why that rule is true. Go ahead, Jenny.
So just like when you cut a pizza into 8 pieces, you're not cutting it as much, so they stay bigger.
Okay? Yeah. Right? Does that make sense? Okay, Elena? Okay, what did she just say? She said when I'm cutting a pizza into 8 pieces, I'm not cutting as much as in 16. So what I am saying, what she just told us, is that I have a pizza, right? And I have cut that pizza into 8 pieces, yes? Well, let's say I'm not cutting that pizza into 8 pieces. I'm cutting that pizza into 16 pieces. What happens? The size of the piece, it gets smaller. So that's why The larger the denominator, the smaller the piece, because the more pieces that I break the whole into, the smaller those pieces have to be in order for them all to be the same size. All right, so Elena, will you please explain to me why, when the denominators get larger, the pieces get smaller? Okay. When the denominator gets larger, the pieces get smaller. Why is that true? Say it again. I think you're right. I'm missing the last part of it. I can't hear you because you start out softly and you get softer. Okay, yeah, when I divide it into more pieces, the pieces have to get smaller. Because the size of the whole doesn't change, right? If I have a candy bar and I'm sharing with a friend and another friend walks in, the size of the candy bar doesn't change, right? So what has to change? The size of the pieces that I'm sharing. All right? So, say it again. The larger the denominator, the smaller the pieces. And what does the denominator tell me? Okay, how many pieces the whole is divided into. Now, we talked about, last week, we talked about equivalent fractions. What is an equivalent fraction? Okay, Angel says that an equivalent fraction is equal. What does she mean by an equivalent fraction is equal? Jenny?
They have the same size part.
I think you're close. I think, because what you're saying is not exactly right, but I think what you mean is exactly right, if that makes sense. Equivalent fractions are the same size piece of the whole. Right? So when I say they're equal, they represent the same size piece of the whole. Right? 1/2 is the same size piece of the whole as 2/4. Agreed? All right, so that's an equivalent fraction. Now, how do I make an equivalent fraction? I don't want to add.
Multiply.
I multiply by the same number. I multiply the numerator and the denominator by the same number. But I can also do what? I can also divide the numerator and the denominator by the same number. And when I am finding an equivalent fraction by dividing the numerator and the denominator by the same number, I call that when I am making an equivalent fraction by dividing the numerator and the denominator by the same number, there's a special term for that. What is it called? Simplifying fractions, yes. Do what? I didn't hear you. If you say it loud enough for me to hear, then you get credit for it. If you say it real quietly because you're afraid you're going to get it wrong, then you don't get credit for it. So just say it loud. All right. So there's where we have gotten to. So now we're going to talk about common denominators. What does common mean?
The same in some way.
The same, yeah. So common denominator means the same denominator. Okay? Because when I compare fractions, I can only compare fractions that are talking about the same size whole, right? Yes? You know, because remember we talked about that? Like, I can't compare, remember the dimes and the nickels? Everybody got 3, but they didn't have the same amount because they were comparing different things. All right, we are in our big reading books, and we're on page 239. Big math book, I'm sorry. Thank you. All right, we're on page 239 of our big math books. All right, so sometimes I need to find equivalent fractions in order to work with a number, in order to work with a fraction, in order to be able to compare it, in order to be able to add it or subtract it. Sometimes I need to find an equivalent fraction in order to work with the number. And all right, so commonly or usually when I have to do that, I'm finding what's called common denominators. All right. So, I want you to take your first piece of paper. All right, Martin has 2 cakes that are the same size. So you should have 2 blank pieces of paper on your desk. All right? One cake is cut into 1/2 size pieces. The other cake is cut into 1/3 size pieces. He wants to cut the cakes so they have the same size pieces. How can he cut each cake? So I'm looking at 2 fractions. 1/2 and 1/3. He wants the denominators to be the same. Now I have to find equivalent fractions for each of these fractions where the denominator is the same. So here's what I'm going to do. I want you to take your first piece of paper, and we're going to use this. I want you to fold it in half. I would say hamburger style, but it really doesn't like this. Okay, so here is the first cake. Now, the second cake, so put your first cake aside. Now, the second cake is divided into thirds. Here's how I divide into thirds. I think about it like a letter. And so I kind of fold the 2 ends to each other. You didn't even try. Okay, no, you're not doing this paper. There's the half paper. And you put the half paper down. And now you have another piece of paper. And I'm going to take one end of this piece of paper. All right, you guys, when you sit there and tell me you can't do it and you haven't even tried it, I feel frustrated. Okay, I'm going to do it with the green paper so you can see better. Okay? So, what I do is I fold over one end towards the other end. I don't push it down yet. I'm not doing the half. Here is my half. I fold my half in half and I put it on the side of my desk and I go hands off. Guys, I told you guys to put it down like 3 times and some of you are still folding the same piece of paper. Okay, now I take my other piece of paper. Remember, I gave you 2 and I said you're going to need 2 pieces. Now, I'm folding this in thirds. So I fold one side towards the center. Now I'm going to fold the other side towards the center and I'm going to kind of hold it loosely until the ends meet. Then I can push down in the middle and make my crease. It may not be exactly perfect, but it will be okay. So when I do that, I have my paper divided into thirds. Well, no, you're folding it the long way. You can do it the long way, that's okay. So when you're done, you should have 3 sections of your paper. So this piece of cake is divided into thirds. So I have 2 pieces of paper. One is divided into halves. And one is divided into thirds. Okay, well, you just have to change it so it's into thirds. All right, maybe this will make it, this is easier because we have done this before. Y'all did this when you were making your fraction cards. So maybe giving you the paper is complicating it for you instead of simplifying it. So let's try it this way. All right. I have 2 pieces of paper. I have 2 cakes. One is divided into halves. And one is divided into thirds. Alright, now, I would like to add lines so that they are both cut into the same number of pieces. All right, so let's look here. If I add 2 lines to my halves, okay, and I, in essence, fold my halves into thirds, how many pieces does this cake have now? 6. All right, so my 1/2 I changed into 6. So these are cut into 1/6 pieces now. Now I take my thirds and I divide those thirds into half. How many pieces is this cake now cut into? 6. All right, so now both of his cakes have the same size pieces. What? That's okay. What I need you to see is that I was able to to divide the cake so that they're both divided into the same size pieces. Okay? Now I can compare because the size of the pieces are all the same. I've found the common denominator. The common denominator is 6 because, So if I have 1/2 and 1/3, all right, and I want my denominator to be 6, all right, 2 times what equals 6? 3. So I need to multiply the 1 by what? 3. So 1 times 3 equals 6. So I have 3 6. That's the same as my 1/2, right? 3 6. That's the same as 1/2. All right. Now when I look at 1/3, let's see. That would be 1/3. 3 times what equals 6? 3 times 2. So what am I going to multiply this 1 by? So 1 times 2 is 6. So 1/3 is equal to 2/6. So what I've done is I've taken these fractions and I've changed them to equivalent fractions that have the same denominator. So then I can compare them more easily because I'm dealing with the same size piece. All right? Let's look at this in different ways. All right. So let's look at page 240. All right. When I look at common denominators, I usually want to find the lowest common denominator. And that's going to be the lowest common multiple. Remember, multiples are numbers that I get when I multiply. So, for example, if I want to write 4/2 or 4/5 and 1/2 as a pair of fractions with common denominators, I'm going to start with the multiples of 5 and 2. So let's go with the multiples of 5. 5, 10, 15, 20, 25, 30. All right, let's do the multiples of 2. 2, 4, 6, 8, 10, 12. What is the lowest number that's on both of those lists? What? Alright, so here is my list of multiples of 5. Here is my list of multiples of 2. What number is on both lists? 10 is on both lists. It is the lowest common multiple. So that is going to be my common denominator. So I'm going to write my denominator in to my new fractions, to my equivalent fractions. Now, tell me again how I form equivalent fractions. What do I have to do to make an equivalent fraction? I multiply the numerator and the denominator by the same number. So, when I look at 4/5, I multiplied 5 times what number to get 10? 2. So what do I have to multiply the numerator by in this fraction? 2. What is 4 times 2?
8.
Okay, so the equivalent fraction for 4/5 is 8/10. Right? Now, what did I multiply 2 times to get to 5, or to get to 10?
5.
2 times 5 equals 10. So, what do I need to multiply the numerator by?
5.
What is 1 times 5?
5.
All right? So, if I want to write 4/5 and 1/2 as fractions with common denominators, what are the two fractions I'm going to write?
First it would be 8/10 and 5.
8/10 and 5/10. All right, are 4/5 and 1/2 equivalent? Well, but when I change 4/5 and 1/2 to equivalent fractions with the same denominator, do I get the same number?
No.
No, so they're not equivalent. Because 1 is 8/10 and 1 is worth 5/10. So they're not equivalent. Now, that's one way to determine if fractions are equivalent, is I can find a common denominator and then compare the fractions using the same size piece. What's another way you can determine if fractions are equivalent? Helena, you were just saying it. I can cross multiply. So when I cross multiply, then I see that 4/5 is greater than 1/2. All right. I want a common denominator for 1/3 and 1/12. All right, if I want to divide this third into 12ths, I need multiples. It's going to be multiples. First of all, is 12 a multiple of 3? Yes. Okay, so chances are very good that the lowest common multiple is going to be 12. So if I take this model that's divided into thirds, let's divide it into 12ths. So let's see, now it's in 6th. All right, so now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, 1/3 is equal to how many 12ths? How many, Angel? It's 4. 1/3 is equal to 4/12. How do I know this? Because what? Okay. When I divide the thirds into 12, and it was already, 1/3 was already colored, so now 4 parts are colored. So yes, I can look at the model. I can also say that 1/3 and 4/12 are equivalent fractions because I can multiply the numerator and the denominator by 4. And I get 4/12. All right? When I look at 1/3 and 1/12, what would be the common denominator? Remember, the denominator is the number on the bottom, and it's the same. So when I find equivalent fractions so that they both have the same denominator, what is the common denominator? Okay, the common denominator is 12 because they are both divided into 12 pieces. So I'm looking at 4/12 and comparing it to 1/12. And when I look at these fractions, the denominators are the same. The common denominator is the denominator that is the same. That is when I find a denominator, find equivalent fractions that have the same denominator. So when I'm looking for the common denominator, I find equivalent fractions that have the same denominator. So I'm looking for equivalent fractions that have the same denominator, and that is called what? A common denominator is when I find equivalent fractions with the same denominator. When I find equivalent fractions with the same denominator, it is called a common denominator is when I find equivalent fractions with the same denominator. So when I find equivalent fractions with the same denominator, I am finding the common denominator. Common denominator. Say it.
Common denominator.
What is it?
Common denominator.
Ray, what is a common denominator? Taraji, what is a common denominator? Jeremiah, what is a common denominator? Jaden, what is a common denominator? You're close. You're getting there. If I want you to find the common denominators, what are you going to look for? What are you going to find?
The same number of the denominator.
Okay, that means both fractions have to have the same number in the denominator. But can I just change the denominator into the same number?
No.
I have to change the fractions into equivalent fractions, right? Why do I have to change the fractions into equivalent fractions? It's not amusing. All right. If I am asking you to do a math problem with the number 2/3, then in order to get the correct answer, then I always have to work with the number 2/3, right? Yes? I can't just change that number, right? I can't just decide, oh, I don't need 3 to be my denominator. I need something else. I'm going to have 8 be my denominator, and I'm just going to make up a number. Because what have I done here?
You changed the answer.
I've changed the number. Right? I've changed the meaning here, because 2/3 does not mean the same thing as 2/8. So if I have to find a common denominator, why do I need to make sure it's an equivalent fraction? Why can't I just make up a number? Why do I have to make sure that I go through and I find an equivalent fraction?
Because if you make up a number, you'll get a different one than what the answer, one of the answers would be.
Because I have to keep working with the same numbers, correct? If I just make up a number, I have changed the number. If I find an equivalent fraction, it's the same, it has the same meaning. And I have to keep the same meaning. Right? I can change the way it looks, but I have to keep the same meaning. So I could say 4/6 because 4/6 and 2/3 is an equivalent fraction. Because I can multiply the numerator and the denominator by 2. But I can't say 2/8 because they are not equivalent fractions. So 4/6 and 2/3 have the same meaning. That's the same size piece of the whole. 2/8 has a completely different meaning. That's a different size piece of the whole. So why do I have to find equivalent fractions, Cody? To what? I can't hear you. Why, when I'm finding a common denominator, why do I have to use equivalent fractions? Right. Yes. Because I can't change the number. And if I find an equivalent fraction, I'm not changing the number. All right, let's look at page 241. All right, I want to write the pair of fractions as a pair of fractions with a common denominator. So here's what I'm going to do. I'm going to write my fractions here. Then I'm going to write my denominators over here. I've got a 4 and I've got a 2. All right, I want to write the multiples. What are the multiples of 4? 8, 4, 8, 12, 16. We can stop there. All right, what are the multiples of 2? 2, 4, and as soon as I get to a number that I have up here, I can stop. As soon as I get to a number that I have up here, I can stop. So what number do I have on both lists? 4. All right, so my common denominator? 4 is my common denominator. All right? 4 times what number equals 4? 4 times 1 equals 4. So, I multiply the denominator by 1. What do I have to do? What do I have to do? I want to make an equivalent fraction. What do I have to do to make an equivalent fraction? By the same number. So if I multiply this denominator by 1, what do I have to multiply this numerator by? 1. What is 1 times 1? All right? There's my first equivalent fraction. It happens to be the same fractions. So I don't have to do anything to that fraction. Now, what about this fraction? 2 times what equals 4? 2 times 2. So what do I need to multiply this numerator by? 2. So 1 times 2 equals? 2. So what are my pair of fractions? 2/4 and 1/4. All right, let's look at 3/4 and 5/8. All right, let's do this. Let's do, what are my two denominators? 4 and 8. All right, I'm going to write my multiples of 4 and 8. I'm looking for the lowest common multiple. So let's list the multiples of 8. 8, and 8 times 2. 8 times 3. 8 times 4. All right, let's list the multiples of 4. 4 times 1. 4 times 2. Do I have to go any further? Nope, because I have a common multiple. What is the common multiple? 8. So what is my common denominator going to be? 8. So let me write my fractions. I have 3/4 and I have 5/8. Okay, my common denominator is 8. All right. 8 times what equals 8? 8 times 1 equals 8. So what am I going to multiply the 5 times? 5 times what? Why do I multiply this 5 times 1, Elena? Why am I multiplying the 5 times 1 here? Elena, why am I multiplying 5 times 1 here? No, Elena Chambliss. I multiplied 8 times 1 here, and now I'm going to multiply 5 times 1. Why am I multiplying the 5 times 1? Jeremiah, what am I doing here? What am I doing right here? What step is this? What? 5 is the numerator. So why am I multiplying the numerator times 1? Thank you so much. And why am I multiplying the numerator and the denominator by the same number, Elena? Why am I multiplying the numerator and the denominator by the same number? What? I multiplied the numerator and the denominator by the same number. Why did I do that? What happens when I multiply the numerator and the denominator by the same number? What have I generated if I multiply the numerator and the denominator by the same number? Yes, I have generated an equivalent fraction, and the rule is I've got to multiply the numerator and the denominator by the same number because